Hello friends, myself Dr. Nandakumar Raubavale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. This is our 12th lecture. In previous lecture, we have discussed how to solve a numerical using Gauss elimination method to get the values of unknown from a set of algebraic equations. Today, we are going to discuss yield condition systems and POT. So now, what is this yield condition of system? The yield condition of system are the set of equations those where small changes of coefficient result in large change in the solution. So what is this yield condition is? Yield condition systems are those where small changes in the coefficient result into large changes in the solution. That is nothing but a wide range of answers can approximately satisfy this set of equations. A wide range of set of answers can approximately satisfy the set of equation. That is algebraic equations. For example, let us consider x1 plus of 2x2 is equal to 10. 1.1 x1 plus of 2x2 is equal to 10.4. So this is set of two equations, equation number 1 and equation number 2. Now if we want to solve it by using Cramer's rule, we can have first determinant, say determinant D, which is equal to coefficient of x1 is 1 and coefficient of x2 is 2, whereas coefficient of x1 in second equation is 1.1 and coefficient of x2 is 2. So this is determinant 1. If we simplify this determinant, then we get 2 into 1 minus of 1.1 into 2. On simplification, this determinant we get as 2 minus 2.2. 2 minus 2.2. This is minus 0.2. And then determinant A1 we get as replacing first column by constant terms 10, 10.4, 2 and 2. then this determinant a1 we get as 10 into 2 minus 2 into 10.4. So this gives us the value as 20 minus 2 into 10.4. This is minus 0.8. And determinant a2 if we want to find out. So first column as it is 1.1, then 10, 10.4. So on simplification we get 1 into 10.4 minus of 1.1 into 10. This gives us 10.4 minus 11. This is 0.6. Now on simplification, so value of x1 if we want to find out, x1 is equal to, if we see here, a1 divided by d. A1 value is minus 0.8 and d value is minus 0.2. So this becomes answer as 4. And x2 is equal to, what we get here is a2 divided by d. a2 is nothing but 0.6 minus 0.6. This is minus 0.6 divided by minus 0.2. This gives us answer as 3. So now here x1 is equal to 4, x2 is equal to 3. Now let us see another example where we are going to change minor change in the coefficients and how it leads to the change in the answer. So let us see second set of equation. So original set of equation is x1 plus of 2x2 is equal to 10. This was equation number 1. And second equation is 1.1 x1 plus of 2x2 is equal to 10.4. So this was equation number 2. Now we want to change this equation, or very minor change in this equation we want to make. The coefficient of x1 in second equation we want to change. So here we'll have a new set of equations such as x1 plus of 2x2 is equal to 10, and in place of 1.1 very minor change we do it as 0.05 x1 plus of 2x2 which is equal to 10.4. So now we consider this as equation number 1 and this as equation number 2, and we try to find out its a solution. So now we'll have determinant d, that is nothing but coefficient 1, 2, 1.05, 2. Then the value of this determinant is 1 into 2 minus of 2 into 1.05. So this changes to 2 minus of 2 into 1.05. So this becomes minus 0.1, whereas determinant a1 if we calculate, now this is 10.4 first column from this constants, and second column remains as it is 2. Then determinant a1 is equal to 10 into 2 minus of 2 into 10.4. So this is 20 minus 2 into 10.4. This is going to be minus 0.8, and determinant a2 now we can write as 1.05 as it is. So this second column is replaced by constants 10.4. Then we take determinant value as 1 into 10.4 minus 10 into 1.05. So on simplification, we get this as 10.4 minus of 10 into 1.05. This is going to be minus 0.1. Now if we try to find out values of x1 and x2, so x1 is equal to a1 divided by d. So a1 value is minus 0.8 and d value is minus 0.1. So answer will be 8. And if we want to find out x2, so a2 divided by d, a2 value is minus 0.1 and d value is minus 0.1. So this is going to become 1. So now here we have solved two sets of equation. In first set of equation, we obtained x1 as 4 and x2 as 3. x1 is equal to 4 and x2 is equal to 3. So just let us see. In first case, we have x1 is equal to 4 and in, x2 is equal to 3. Whereas in second case, x1 is equal to 8 and x2 is equal to 1. So this difference you can find here. So this difference in these two answers is because of minor change in the coefficient. So this minor change in the coefficient is because this minor change which is made in the coefficient of second equation leads to the new answer. Now if we substitute these answers in the first set also, so probably it may satisfy this second set also. So say for example, first set of equation. So let's have a new slide. So x1 is equal to 4, x2 is equal to 3 in the second set, and x1 is equal to 8 and 1, 8 and x2 is equal to 1. So the original set of equations which we have is x1 plus of 2 x2 which is equal to 10 and 1.1 x1 plus of 2x2 is equal to 10.4. So now if we substitute a first set of values in this original equation, so for example substituting x1 is equal to 4 plus of 2 into x2 is equal to 3, 4 plus 2 6 plus 4 is equal to 10. So this satisfies first equation. Now if we substitute values of x1 x2 in second equation, 1.1 into 4 plus of 2 into 3, so again, so this 4.4 plus 6, that is 10.4. So first set of answers, that is 4 and 3, satisfies first and second equation. Now let us see this second set of answer in this original equation, equation number 1. So if we substitute x1 as 8 plus of 2, x2 is 1, so then this is 10. So again this second set also satisfies first equation, and if we substitute second set in this second equation, then if you see 1.1 into x1 value is 8 plus of 2 into x2 value is 1. So this can be simplified as 8.8 plus of 2. So approximately this is 10.8, and this 10.8 is very close to 10.4. So this is the actual value of the second equation. So now 10.8 is also satisfying this second equation, and that is nothing but second set of solution is also approximately satisfying the set of equation. That, as we told here at the initial stage, wide range of set of answers can approximately satisfy the set of equations. If there is a minor change is made in this coefficient, then the set of equations or set of answers can satisfy the equations. That is nothing but there is the slope of these two equations are going to be very close, and such a set of equations is known as the ill condition systems. So we have discussed one problem in your one of the lecture, graphical method. So we had plotted two equations which were like this, having the same slope. So it was third case. There were two equations or two lines which were going to overlap. So this is first line and second line. These two lines are going to overlap with each other. So first equation was minus 2.3 divided by 5x1 plus of x2 is equal to 1.1, and second equation was minus 1 by 2 x1 plus of x2 is equal to 1. So these two equations have got same slope. So this is minus 1 by 2 means minus 0.5, and minus 2.3 minus 2.3 divided by 5 is also again this is equal to 2.3 divided by 5. This is also minus 0.46. So minus 0.46 and minus 0.5, that is minus 1 by 2 is equal to 0.5. Slope of these two lines is very close to each other. Minus 0.5 is very close to minus 0.46. That is nothing but ill condition makes us not to understand where these two lines are going to intersect. So exactly point of intersection we cannot identify, and because of that the values of x1 and x2 unknowns, x1 and x2 cannot be predicted exactly. So whether these two lines are intersecting here or here or here, so it makes confusion, and because of that all these values which are very close to each other are going to satisfy both the equations, and that is called as a ill condition. So now we'll have theoretical discussion over this ill condition. So now we can see there is equation a11 x1 plus of a12 x2 which is equal to c1, and a21 x1 plus of a22 x2 which is equal to c2. So to find out these values of x1 and x2, so just we want to find out x2 in second equation, first equation, equation number 1 and equation number 2. So transferring this term a11 x1 on right hand side, just we are converting it to the equation of straight line. So a12 x2 is equal to minus a11 x1 plus of c1, or x2 is equal to minus a11 divided by a12 x1 plus of c1 divided by a12. So this we call as equation number 3, which is obtained from equation number 1. Now converting equation number 2 into the equation of straight line, we get, that is a22 x2 is equal to, transferring this term a21 x1 on right hand side, a21 x1 plus of c2, or this can be written as x2 is equal to minus a21 divided by a22 x1 plus of c2 divided by a22. So this is equation number 4. So now what we can see here, we have two equations of straight line, equation number 3 and equation number 4. So here this term coefficient of x1 gives the slope of first line, and coefficient of x1 in equation number 4 gives the slope of line in second equation or equation number 4. So what we can write is a11 divided by a12, if it is approximately close to a21 divided by a22, On cross multiplying this, we get a11 into a22, which is approximately equal to a21 into a12. So we can also which can also be expressed as a11 into a22 minus this transferring right hand side on left hand side, a21 into a12, and this is approximately equal to 0. That is nothing but if determinant d which we have obtained is approximately equal to 0, then that leads to yield condition. So in previous case what we have seen here, this determinant d which is minus 0.1, which is close to 0 in both the cases, in first case and in second case. Determinant d is minus 0.02, which is very close to 0. So in first case and second case, if we see this determinant which is very close to 0, then the system of yield conditions is going to exist. So this determinant, that is nothing but when we write the equations, then by taking the coefficient of these equations unknowns, we form this determinant, and if this determinant value leads or is equal to 0, then that is the indication that the set of equations are going to yield or are called as a yield conditioned systems. We call it as a yield conditioned systems. So this is what we have understood from this, what is yield condition system. So now we will see what is pivoting. So before looking at pivoting, we'll solve one problem, and then we'll see what is pivoting. Now we'll have one set of equations, say 0.000 3x1 plus of 3.000 0x2, which is equal to 2.0001. So this is equation number 1, say. Then we take another equation, that is 1.0000 x1 plus of 1.0000 x2, which is equal to 1.0000. So this we call as equation number 2. Now let us see, this equation has got the value of coefficient of x1 in first equation at the place of a11 is known as a first pivot element. What we call this a11, that is nothing but which is equal to 0.0003, is known as first pivot element. First pivot element. First pivot element, and it is very close to 0. 0.0003 is very close to 0. Then the computations which will find, and what is effect of this pivot element having 0 value or approximately close to 0. Let us see that the exact solution of these two equations, or the value of x1 is 1 by 3, which is known to us, say, and value of x2 is 2 by 3. So we know the exact result of these two simultaneous equations. So x1 is 1 by 3 and x2 is 2 by 3 is the exact solution for these two equations. Now let us see, let us try to solve these two equations using Gauss elimination method. So solution by Gauss elimination method. Now let us see multiplying equation 1, first equation, by first equation is multiplied by 1 and divided it by 0.003, that is 1 divided by 0.0003, we get new equation as x1 plus of 3 into 1 divided by 0.0003 x2, that is nothing but, if we multiply this term to first equation, 0.003 gets cancelled and only x1 is going to remain, and for second term if we multiply we get 3 divided by 0.0003 which is equal to 2.0001 divided by 0.0003. So on simplification we get this as x1 plus of, so this becomes 10,000 x2, which is equal to 6667, and we call this as equation number 3. So now this equation number 3 can be used to eliminate this first term x1. So equation number 3 is subtracted from equation equation number 2. So subtracting equation number 3 from equation number 2, so we write both the equations here. First equation is, equation number 2 is 1.000 x1 plus of 1.0000 x2, which is equal to 1.0000. So this is equation number 2, and the equation number 3 is coefficient of x1 is again 1, means 1.0000 x1 plus of 10,000 x2, which is equal to 6667. So this is equation number 3. So subtracting equation number 3, so this becomes minus, this becomes minus, this is positive, it becomes minus. The first term gets cancelled, and 10,000 minus 10,000 plus 1, that becomes 9,999, which is negative x2, which is equal to 66667 minus of 1, this becomes minus 6666. So this is, we call as equation number 4. From this what we get, x2 is equal to minus 6666 divided by minus 9999. So this can be called as minus minus becomes plus, and which is nothing but 2 divided by 3. So this results into 2 divided by 3. So now from this this x2, if we substitute back into the equation number 1, so coming to this equation number 1, and if we substitute this x2 value in equation number 1, what we get, that we see in next slide. So equation number 1 is 0.0003 x1 plus of 3.0000 x2, which is equal to 2.0001, and x2 which we have obtained here is 2 by 3. Just now we obtained x2 is equal to 2 by 3. Now we substitute x2 in this equation. Then 0.0003x1 plus of 3 into 2 by 3, which is equal to 2.0001. So 3 gets cancelled, 2 is going to remain. So x1 is equal to, or just if we substitute it as it is without cancellation, so this results into 2.0001 minus of 3, or 2 by 3 into 3 divided by 0.0003. So without cancellation, we have not cancelled, say. This is 2 by 3, 2 by 3. So this is value of x1. So now we'll have one table, and in the table we will see the error in the value of x1, and depending on the significant values of significant figures of this x2. So x2 value is 2 by 3. So here what we have substituted, 2 by 3. So now we will see, we'll have one table, significant figures. And first we have x2 value, then we have x1 value, and a relative error. The error for x1 value. So now we say 3 significant figures for x1. So x2 value. So x2 value, if we take 2 by 3 as 0.667, then the value of x1, which we get by simplification of this equation, say equation number 5. So this x2 value, this is 2 by 3 is nothing but x2 value. x2, if we substitute 0.667 up to 3 significant figures, so x1 value will be minus 3.33, and this error of x1, so x1, exact value of x1 which is given in this problem is 1 by 3. So 1 by 3. Now comparing this with 1 by 3, this is true value, and this is minus 0.333 is approximate value of x1. This is approximate value. So we can find out relative error, which is equal to true value, difference of true value minus approximate value divided by, we can say, this true value into 100. So now this relative error we find here as 1099%. This error is 1099%. Now if we take up to 4 significant figures, this x2 value as 0.6667, then x1 value will become 0. x1 value becomes 0, and this error is going to be, this error is going to be 100%. And if we take it up to 5 significant figures, x2 value, that is 2 by 3, as 0.66667, then x1 value yields as 0.330000, and this error sorry, this is 0.3 only, then this error reduces to 10%. And if we take it up to 6 significant figures, that is point x2 value as 6 up to 6 significant figures, 6666667, then the value of x1 is going to be 0.330000, and this error reduces to 1%. And when we take it up to 7 significant figures, that is 0.666667, then the x1 value is going to be 0.3330000, and this error is going to become 0.1%. So now what we can see here, this error is proportional to the number of significant figures, inversely proportional to number of significant figures. If we take only up to 3 significant figures, relative error is higher, and if we take up to 7 significant figures, then this relative error is going to reduce. That means the error is introduced depending on the number of significant figures of this x2. So this is we call as a without pivoting. Without pivoting, the error is inversely proportional here to number of significant figures we consider. Now we will have another example. Same problem we will be solving with a different way. Now we have two equations, so equation number 1 and equation number 2 we have simplified. Equation 1 and equation 2 we have simplified. Now these two equations we will interchange. So first equation is brought at the second and second is brought at the first. So pivoting element a11, which was very close to 0, now if we interchange these equations, so pivoting element will become 1.00. so this pivoting element will be this 1 will become pivoting element. Now we will rewrite these equations. That is, equation number 2 is written as equation number 1, 1.0000 x1 plus of 1.0000 x2, which is equal to 1.0000. So this equation number 2 is written first and second is first is written second. So we write this as 0.0003 x1 plus of 3.0000 x2, which is equal to 2.0001. Now to eliminate first term here, and for eliminating this we have to multiply it by 0.003, multiplying now this is equation number 1, this is equation number 2. Equation 1 by 0.0003 and dividing it by 1, we get first equation is multiplied by 0.003 and divided by 1, so then it becomes 0.0003 x1 plus of, so into 1, this is 0.0003 x2, which is equal to 0.0003. so we call this as equation number 3. subtracting equation number 3 from equation number 2. Equation 3 from equation 2 we get, now equation number 2 we write first 0.0003 x1 plus of 3.0000 x2, which is equal to 2.0001. This is equation number 2, and equation number 4 is 0.0003 x1 plus of 0.0003 x2, which is equal to 0.0003. So this is equation number 4. So now subtracting this equation number 4, we change the signs, minus, then this first term gets cancelled, so 3 minus of 0.003, we can get here it as just a minute. minus 0.0003. So this is going to become 2.9997 x2, which is equal to 2.0001 minus 0.0003. So this is 1.9998. So x2, if we get here, we get it as 0.66666666. That is nothing but indirectly we can call this as x2 is equal to 2 by 3. x2 is equal to 2 by 3. So if we simplify this, we get x2 is equal to 2 by 3. Now substituting this x2 value in equation, any one of the equation, so substituting x2 in first equation, so first equation is 1.0000 x1 plus of 1.0000 x2 is equal to 1. So this is first equation, and we want to substitute x2 is equal to 2 by 3. So 1.0000 x1 plus of 1.0000 x2 value is 2 by 3, which is equal to 1. So x1 is nothing but 1 minus 2 by 3. So x1 is 2 by 3 divided by 1. Now this we will have a table again to find out the error. So we will see next page. We will have a table, significant figures. Then x2 value, then x1 value, and relative error. Now first we take 3 significant figures for x2 value, that is 2 by 3 was x2. So 2 by 3 means we consider it as 0.667. Then x1 value, so x1 which is given by this equation as x1 is equal to 1 minus 2 by 3. x1 is equal to 1 minus 2 by 3. 2 by 3 means it is x2. x1 is equal to 1 minus 2 by 3. So here we get x1 as 0.333. Then relative error is 0.1% here. Relative error we get as 0.1%. If we take it up to 4 significant figures, then 0.6667, and this x1 value we get as 0.3333, and this relative error becomes 0.01. So if we take it up to 5 significant figures, 0.666 6 7. If we take x2 value up to 5 significant figures, so then x1 value is 0.33333. Then the error gets reduced to 1.001. And if we take it up to 6 significant figures, that is 0.6666667, then this becomes 0.333333, and this error gets reduced to 0.0001. So on. So what we can find here is, in first case, so the error was here it was 10, 99, 100%, 10%, 1%, and 0.1%. so depending on significant figures. So if we take it up to least number of significant figures, error was larger, and if we move up to higher significant figures, error was going to be 0.1%. so when we have taken x2 value correct up to 7 significant figures, at that time we got 0.1 as the relative error. But in second case, what we obtained here is, in first step itself, when we have taken the value of x2 up to 3 significant figures, the error is 0.1. so this case was there when we have taken the value of x2 up to 7 significant figures, so this was the error. That means what we did here, same equations we have solved, only we have changed the pivoting element. So this 0.003 was at the place of a11. Now we have transferred this second equation to first, that is nothing but a11 has become 1.0000, that is 1. That is nothing but the pivoting element. If it is very close to 0, if a11 is approximately equal to 0, then the answers are sensitive to significant figures. Therefore this is done by pivoting. So instead of keeping this equation having very low value or approximately 0 value or close to 0 in this pivoting position, so that is altered. So this is called as a interchanging the equations in order to have this a11 as the element having higher magnitude. That is called as a partial pivoting. This is called as a partial pivoting. We call this as a partial pivoting. So what is partial pivoting? Only the equations are interchanged in order to have the coefficient of first variable, first unknown, which is having highest magnitude at the first place, that is in the place of a11. So that is known as a partial pivoting. So partial pivoting avoids us to have the which helps us to have the accurate answer with least number of significant figures. So this is the advantage of pivoting. So this is called as a pivoting. What is pivoting now? Interchanging equations in such a way that the coefficient or a11 element will be far away from 0 or which is not close to 0, so that the answers will not be sensitive to significant figures. So that is nothing but pivoting. So here we have interchanged the equations in order to have the solution which is not sensitive to significant figures. So now in next class we will be looking at what is complete pivoting. So this was partial pivoting, what is complete pivoting, and what is scaling. That will be dealt in next class. Thank you.